So for today's video, we are going to integrate using miscellaneous substitution. So let's have an example first to elaborate further um, the topic. So integral of dx over square root of x multiplied by 1 plus cube root of x. So the first thing we need to do is we can rewrite our denominator as x to the 1/2 multiplied by 1 plus 1 plus x to the 1/3. So multiply, so we will have x times x raised to the power 1 plus x times 1x to the power of 1/2 multiplied by x raised to the power of 1/3 is we will get x to the 5/6. So we can now integrate this in terms of z. So to find let's have this rule that x to the x is equal to the z to the n, in which n is the least common denominator of these two exponential fraction. So x is equal to z. All we need to do is multiply 2 and 6 to get the n, or the least common denominator. So 12 times 6 is 12. So find the derivative of x. Dx is using the derivative rule, power rule, is 12 12z raised to the power of 11 dz. Right? So we can write this as the integral of our dx is 12z raised to the power of 11 dz over, so our denominator now is x to the 1/2 plus x to the 5/6. So to find in terms of z, all we need to do is x to the 1/2 is equal to z. Our z is 12. So all we need to do is multiplied by 1/2. So to get, we will now have this z is equal to 6. So x to the 5/6 is same process. Z to the 12 is to 1/3. Our z is equal to 4. So we can write this as terms of z. Our x to the 1/2 is z to the 6 raised to the power 6 plus z to the raised to the power 4. So notice that we can divide 6 raised to the power of 11. So we'll now get this. We can move this 12 here, 12, and we will now get the z to the 5 1 plus z to the 4. So all we need to do now is divide this term. So z raised to the power 5 divided by 1 plus z to the 4. So we also z, we can see that z times z to the power 4 is z to the 5. Z times 1 is also z plus z. So z, so subtract z to the 5 is 0, subtract z plus minus is equivalent to negative. So we can rewrite our integral as 12. So z plus the remainder z over 1 plus z to the 4. So we can now separate this into two integral parts. So 12 integral of z dz negative z over 1 plus z to the 4th dz. So now we can find the antiderivative of these two integral functions. So then the antiderivative of z is simply z to the squared using the power rule over 2 root 2 minus take the antiderivative of z negative z over 1 plus z over 4 is using the trigonometric identities. We can say that it's tangent, and also we distribute this negative sign, so x times no, negative times positive is equal to negative. So we can now have tangent z squared. Z squared is the antiderivative of z is z squared over 2. So we can now substitute z in terms of x. So to find the x is we now have x is equal to z to the 12. So all we need to do is multiply it by 1 over 12. Also here 1 over 12 in x. So we can now have z is equal to x over 1 over 12. So replace z in terms of x. So z is x to the 1 over 12 multiplied by squared over 2 minus tangent z, or z is x to 1 over 12 times 2 over 2. So we can continue it here. So x to 1 over 12 multiplied by raised to 2 is, so x is 1 over 6 over 2 over don't forget to write the 12. So minus tangent x. So x is raised to 1 over 12 raised to 2. So we can now we will get a 6. Sorry, this is 6. By the way, this is 6 over 2. So distribute 12. So we can now have a 12x over 6 minus 12 tangent x over 1 x raised to the power of 6 over 2 over 2. So our final answer is 6. Can divide this as x is equal to 1 over 6 minus 6 tangent x over 1 over x raised to the power of 1 over 6 plus c.